All right, folks, welcome back. Tuesday night. So we're going to dive back in and try to remember where we were in our little setup. So before, which I think I closed, hang on, let me get logged back in. Before the stream, I got everything redeployed from last week. Just give me a second here. All right. So here we go. All right. Go over to, wow, what am I doing here? CloudFormation, that's it. Right, and we redeployed everything before the stream. So reset IAM, deployed the VPC, set up the security group, set the cluster up, and then deployed the Fargate profile. So if I go over to EKS, right, here's our cluster. There's no nodes running, right? We do have core DNS services, which I think we have to make a change to because we're using Fargate profiles. But to be honest, I haven't had a lot of time to look this week, so we're gonna have to kind of wing some of this. And without going through the rest of this, we go over to the config. Here's the details of our cluster, right? No node groups because we're trying to do the Fargate thing. Here's our networking setup. We were looking at add-ons last week, so I think we'll go back and work on these a bit. We don't have an OIDC provider. We set up the logging, right? No update history or anything like that. So if we flip back over here and we drill into the Fargate profile, these are the subnets where it'll launch the pods, right? There's our profile ARN for the Fargate. There's the role that'll be used to execute our pods. And then we set up a really simple pod selector. I think all we did was set the namespace. We didn't set any key value pairs or anything. So we got to maybe figure that out as well. Okay. The other thing that I thought we could do today is set up Cube Ctl. I don't want to set Cube Ctl up on my workstation, so I thought we could kind of build out some simple templates to stand up an EC2 instance, and just to keep it clean, put all the kubectl configs and everything on that EC2 instance rather than messing with my own setup. I know we could do Docker or anything like that, I guess, but I figured this would be the easy way. So maybe what we'll do is we'll start with an EC2 instance that we can use to install kubectl and get it connected to our cluster. Thinking that's maybe what we'll try to get accomplished tonight. Okay, so let's get to it. And I'm not going to put the EC2 instance in the public subnet. We're going to use Session Manager to get to it. For tonight, we'll just use Session Manager through the console, but maybe later we could figure out how to set up Session Manager and we could just use it from command line. So this will be pretty simple. What I'm going to do is create an IAM role that will provide the what's the word I'm looking for? Access to SSM on the EC2 instance, and that should be all we need to do. And then I'm just going to set up a standard, I think I'll just use Amazon Linux, right, to do this. So the first thing is IAM. So let's do that. If I can find it in the list. Here we go. What we need is a role, right, with I think it's just a single managed policy. We'll double check. So a single managed policy associated to the role, and then we take that role and we associate with the instance profile. And then we can refer to that instance profile in our EC2 config. Okay, so let's close these down. We already have this set up. And these are where we've got our original roles. So there's our cluster role, there's our profile or our pod role for Fargate. What we'll do then is just create, actually let's call this, let's just call it EC2 role. And then we need our assume role policy document. Here's another example of, you would think that this kind of stuff would eventually stick in your head, but I do not remember this ever. The version is 2.12, 10, 17. Statement's going to be easy. It's effect, allow. We want this to be assumed by the AWS service, not AWS service, sorry, the EC2 instance. EC2 service, there we go. I think we can just do this. Okay. The action is just one action, STS assume role. And I think that's all we need for the assume role policy doc. We'll give it a description just to help us remember later. So EC2 role for EKS demo project. And we want to add manage policy ARNs. Okay, we'll come back to that. You know, we could do something fancy. Why don't we do a permissions boundary just so we can? Permissions boundaries, if you're not familiar with them, it's a little silly example in this case, but think of it as a way to filter permissions. So what does that mean? In this particular situation, we have STS, right? So the security token service. But what's to stop somebody with enough access to come in here and allow this role to access other services? So what we could do is we could put a permissions policy in place that allows us to set the maximum permissions provided or allowed by this particular policy document. And the way you think about it is where the policy or where the permissions overlap is what's allowed. So here's a simple example. Let's say you had a IAM policy. Forget the role for a second. Say you had an IAM policy that allowed a user access to, I don't know, EC2, RDS, and S3. And maybe you just did it like, you said EC2, well, let's not get into the details, just those three services. And then you created a permissions boundary. And in that permissions boundary, you just had EC2. And you assign the permissions boundary to that user. And what it's going to do is it's going to filter the permissions based on the permissions boundary. So even though the user in an identity policy is allowed access to EC2, RDS, and what did I say, S3, the permissions boundary allows access only to the EC2 service. So the other permissions that we assign to that user aren't available anymore. They would get an access denied error. We could maybe look at that. Might be kind of interesting just to see how it works. It's kind of not really required for this, but we might look at that. Role names and tags. So let's tag this just like we've done all the other. Oh, look, we didn't add tags here. Okay, well, let's fix that. So we'll go back over to here. We'll borrow this. Oops, not delete it. Borrow it. And we're going to add that right here. We're not going to worry about the name. We'll let CloudFormation name this for us. And then I'm going to take these and I'm going to add these tags to our other roles. Okay, so we added the missing tags. And now what I need is I need the ARN to provide us access to the SSM service. So if I go back over here, go to IAM, and for what we're doing, we just need a single policy. So this is the original policy. If we look at this here, you'll see a note in here, and it'll say that it's being deprecated. So use this instead. So if we go back over here, do that search again, maybe. Nope. This is what we need right here. So we can just grab the ARN from here and dump it over here. Okay, easy. And now, if we were doing this through the management console, when we create the EC2 instance, or when we create the role through the management console and we associate it to the EC2 service, it will automatically create the instance profile. But in this case, we have to do that ourselves in this particular situation. Sorry, I'm messing with my camera here. It feels a little tight today for some reason. Okay, so we need to now create the instance profile and make that association. So we'll just call this instance profile. And if we go back over here, there's our instance profile. We're not going to give it a name. We'll let Amazon again take care of that for us. This does depend on the EC2 role to be there first, so we'll just put that in there to be sure. And then we say roles. What is it asking for? The ARN or a name? The name of the role. So if we go back here and look at our return values, okay, so it's just a ref. So all we need here is we can say ref EC2 role. That's it. Okay. And then let's add here to instance profile just to continue setting up our outputs. And what does the instance profile output for us? So again, this gives us the name, this gives us the ARN. I can't remember what we need for the, we'll probably just create a launch template, but I can't remember if we need to refer to the ARN or the name. So let's just do both. We're going to do this. If we do ref, that gives us the name, right? Yeah, it returns a resource name. Okay, so EC2 instance profile. And then we'll say export the name. Let's borrow off of here again. And we'll go okay, so now we have both. We have the name and the ARN depending on what we need. I need to change that because that's, oh no, I did that. Okay, that's fine. Yeah, we're good there. Okay, so let's commit this. All right, so that's done. We won't deploy it yet. The next thing I think we'll do is we'll create ourselves a new folder structure. We'll just call this compute. And for now, we're going to create ec2.yaml. Okay. Let's go over here and grab this. Actually, what I'm going to do is we're going to call this just LT for launch template. We'll put all the details in the launch template. So there's the instance. We're going to do that in a second. This is what we're after here. All right, so let's see. Launch template data. And we got a lot of things that we can include here. So we want to try to build this out so that it satisfies a bunch of the Security Hub requirements for both the CIS benchmark and the, what's the other one? The AWS best practices. I think it's security best practice or foundation best practice. So we're going to put a bunch of things in here. It's complete overkill for what we're doing, but it's a good habit to get into. Right, so the first thing we're going to do is we're going to say block device mappings. We're not going to add anything other than the root drive, but I want to make sure that we're encrypting that root drive. So we're going to say device name. I'm going to have to come back and look at this. I never remember what it is. Okay. We have EBS, so parameters set up for EBS volumes. What is this asking us for? There, that's what we need. So EBS, is it a list or an object? I never can remember. It's just an object. Okay, so we're going to say encrypted. Again, we're going to make this as a to-do for ourselves to come back to. We will need the KMS key ID because we want to use our own what was I going to say? I want to use my own CMK. There we go. We're just going to leave the default drive size at 8 gigs, but we are going to change the volume type, and we're going to use GP3, so the latest generation of general purpose SD. So this is just a Boolean statement, so that's an easy one. We're just going to say true. Okay. This we're going to have to probably set. Do we have KMS? See, we don't even have a KMS key at this point. So we're going to create a KMS key. We'll come back and refer to that there. So that means when we think about parameters, you know, I just made my thing. Okay, so environment, yeah, this is what we want over here. So that's our regular tag parameters. And then stack parameters, we need to pass into this the IAM stack. And we need to pass into it the KMS stack, which doesn't exist at this point. Okay, so what we're going to do is this will refer to the KMS stack. We'll need the IAM stack later for the instance profile. Okay, so there's that. All right, GP3 is what we selected. That's fine. Volume size. I was doing this the other day for something, and I didn't put the volume size in because it's not required. But what I found is it was, I can't remember what the error message was that CloudFormation was throwing at me, but even though it says it's not required, when we were building the launch template, we had to put this in here in order for it to work. And maybe a better way to do this is let's do this. Volume size. And then up here, we can go like this. Volume size, type, number, default 8. Okay, let's also do volume type. This is a string. The default value, make this a little more flexible for later, right? If we ever wanted to change our minds. Allowed value is going to be GP2 and GP3. I don't really ever see needing anything other than those drives. So that we can go here and say ref Oops, sorry, I'm wrong keyboard. There we go. Ref volume type. Okay, so that's the first piece of our device map. Let's go back a couple layers here and keep working through this. Capacity reservation, so we don't need anything there. Sorry, I got a cable falling out of the way here. CPU options we don't need. Credit specs we don't need. Disable API termination. Total overkill for what we're doing, but let's add it anyways. I could spell it termination. Same thing up here. I like to turn this on when we're doing things like we're pushing machines into production. I want to make sure that nobody just accidentally deletes it. So you can see here, if this is set to true, you can't terminate the instance using the EC2 console API or CLI. What we would have to do then is modify the instance to disable this feature before terminating it. Now it's interesting, I'm putting it in caps, but let's just try it like this. I always forget how the Boolean stuff works, the true false stuff works. Sometimes I find it throws errors, but we'll try it. EBS optimized. Again, kind of overkill for what we're doing, but let's build this out. Right, we'll turn that on. We don't need a GPU. We don't need inference. We don't need an enclave, hibernation. Here's the instance profile piece. For now, we'll mark that to do because we'll have to get the import structure again for that. So we'll leave that alone. The image ID. We're going to mark that to do. But what I'm thinking is we will create up here a mappings section. Let's actually do this now. And we're going to call this, I don't know, we'll just call it AMI ID. And we'll just look up the CloudFormation mapping. And this is the structure we need. So there's our section. That's our name. And then what we'll do is we'll do CA-central-1. And we'll just say ARM. We'll go look these up, and then we can do x86. Okay. And I'm just going to put a couple examples in here. You could build this out more complete if you needed to deploy across other regions, but we'll just do the 2 regions for now. And then we have to do the find and map piece, which should be in here as well. Right here. Find and map, so the map name, the top level key, and then the second level key. So this will be find in map. Our map name is just AMI ID. And then we're going to say ref AWS region. So pick up whatever region we're using to deploy this in. Then we can determine what architecture we want. And we're going to do ARM. Okay. So what that'll do is it'll look for that value. Okay. So that's that piece. System profile. We got to do that. We got the image ID. Instant initiated shutdown behavior indicates whether an instance stops or terminates when you initiate shutdown for the instance. That's fine. We don't want to change that. Market options, instance requirements. We don't need that. We need instance type. Now this is another one. I think what we'll do is create a map for this as well, because we're going. How do we do this? Because we're going to have different instance definitions, instance type definitions, depending on the architecture, right? So as an example, the ARM processor could be like, actually, let's do it like this. Let's do Graviton. Okay. So that means like the Graviton instance would be, I'll just make it up, T4G small. If you did the same thing in the x86, it would just be T4 small. So I need a way to look that up as well. I think what we could do is we could probably do this as a map. So let's do instance map, we'll call it. Maybe we'll change this just to keep them the same. AMI map. And now, in this case, we're just going to do Graviton small is T4G small. I don't know if this is the best way to do this, but it should work. T4G medium. And then we'll just say, we'll just do small and medium. And then we'll say if you select x86, then it's T4, not T4, nope, hold on. Try that again. Small, T4, yeah, small. And medium becomes T4 medium. Total overkill for what we're trying to do, but this is the time to experiment a little bit, right? So we'll go back and we'll say instance map. You know, what we'll do is instead of hard coding this, why don't we make that a variable as well? So we can do this. We'll call it instance architecture. Type is a string. Okay, the default is Graviton, and allowed values are, oops. Yeah, that's how you spell it. Graviton and x86. Okay. So now here we can refer to, what did I just call that? Instance arc. That then becomes what we do right here, comma, maybe we do something like this too. We say instance type, or no, instance size. Default is small. Allowed values small and medium, because now I can do this ref instance size. Okay, I don't even know if this is going to work the way that I envision it working, but let's try it. So that's instance type, kernel ID, key name. So we'll say key name equals ref key name, and then we'll add another parameter up here, key name, and we're going to use the Amazon parameter type here for this, so that we just get a list of the key name, the keys that are created. Let me scroll down here. We are after this, so we'll put that right there. So that's our key name, license, metadata. We also want metadata because one of the checks that Security Hub's doing is the version of IMDS you're using, version 1 versus version 2. So we want to make sure that we are using version 2 for our metadata options. And this is pretty simple. What we need to do in here is we need to just say HTTP tokens, and these become required. Okay, so that's going to force us to get a token before we can talk to the metadata. And I think that's all we need here, if I recall. Not required, not required, not required. Also not required, but that's the one piece we need. And then instance metadata tags set to enable to allow instance access to instance meta tags from the metadata, set to disabled to turn it off. Okay, so it's disabled by default. I guess that's fine. Okay, so that gets us down here. Monitoring. Do we want to enable enhanced monitoring? What do we need to do here? Oh, okay. I'm not even going to put this as a Boolean statement or as an option. We're just going to turn on detailed monitoring. Network interfaces, placement, private DNS, RAM, security groups. This is what we need too. So up here, we now need SG stack. Okay. Tag specifications, user data. Well, this one here is, let me just make sure I'm doing this right here. Okay, tag specifications. What's the resource type? That weird space thing. Let's set this up. Resource type is instance. Then we can fix this up. Okay. And then tags. And this still looks like the regular tag structure, so we can borrow that from here. I don't know what I did there, better be careful. This. Okay. Now we do want to set a name here, at least a name for the make sure this is properly tabbed. Yeah, something weird's happening here. Let me just make sure. Okay, that's good. Yeah, I'm not sure what's going on here. Okay, yeah, I guess that's all right. Key name. I don't know if we had this set somewhere else. Okay, perfect. This is what we're after right here. What did I copy out of that? Value. Stack name environment, EKS. We'll just call this, well, we'll just call it, I don't know. Wow. It's not really a bastion, but we're going to kind of use it. Let's call it management, MGMT EC2. Okay. So that's our tag specs. We're good there. And then the last piece was user data. We're not going to worry about any user data. And then if we jump back up to the main launch template, what we've done is to define the launch template data. The launch template name's not required. We'll let CloudFormation do that. And then tag specifications here. So these are the tags to apply to the launch template. So if we go back, we want to line that up right here. So tags specifications again, specifications. And it's a list again. Dash. The resource type must be launch template. And tags, we will just take all of these. We won't worry about the name tag. I'll just let it name that for us. Fix all this up. Oops. Okay. So that's a fair amount of changes to make. So why don't we update this? Okay, and then we'll create a new stage in our CI script. I think I left a lot of to-dos in there. Okay, well, we can do this. We'll just call this mgmt-ec2-EKS. That's good, that's good. We don't need this. SG stack is just SG dash, oh sorry, EKS dash SG. What was the other thing that we added? We had a bunch of stacks right at the top. IAM KMS SG. Whoops, try that again. Okay. I'm going to leave this because I think we're going to need that in the actual EC2 definition because we have to pass in the subnets. So that's fine, that's fine. That we don't need. Okay, this was just how we were generating some randomness in that stack. So this can actually go away here. Okay, so we've got VPC, we've got IAM, we need SG stack. And then we need a non-existent KMS stack. Okay, so that's all that, which we know at this point won't deploy successfully. Pass all that and we have a default. I'm just looking to see if there's any other parameters that we need to send something in with. Key name we need to provide. Where am I going? Back here. And I want to, I think I have a key in here just called demo key. Let's check. Not Elastic IPs. Close. There we go. Yeah, demo dash key. What security groups do we have? Demo SG. I'm going to delete this. I don't think I need it. So all we have is the default security group associated with the VPC that we've set up. And we're going to actually, because we were talking about Security Hub compliance, we're going to edit the default and just delete the rules on that. Okay, so that's good. We got our key name. So that's good. Default, default, default. That's good. And then the rest of this we need to figure out still. So the first thing is, what are our AMIs? I'm sure there's an easier way to do this as well, but here's my way of doing it. We want to use Amazon Linux, and this will be our x86, and we are in, let's make sure we're in the right region first, Canada. Okay, Amazon Linux, there we go. And we want to use x86, so we'll grab that, and that goes here. And then we'll change it to the ARM processor, and that'll give us that. And then we'll switch to here, and we'll do the same thing. So there's our x86, which goes there, and our ARM processor, which goes here. So that sets those up. I'll make a little note here. Default AWS Linux to AMIs 4. Yeah, we'll just do it like that. Okay, so that's good. Oh, I need to know the device name. I want to say, yeah, I don't remember what it is. And I don't have a machine that's running right now. We'll just launch this really quickly. Okay, why don't we have any subnets? Oh, sorry, I'm in the wrong region. We deployed everything in Canada. Oh, look at that. Okay, that doesn't matter. We can fix that. We'll just create a demo key over here. That's what I'm after. This doesn't matter. Really, all I'm after at this point is the name, like the /dev/ what is the device name or device ID for the wow, I'm having a problem with remembering what I'm talking about here. The default EBS volume. There we go. So none of this matters. Does it give us the, it does not give us the volume there. So we're just going to launch this. This is going to just last long enough for me to go over to volumes. This is the root volume. And what I'm after is, actually, I think you see it on the EC2 page. Go back over here, go to storage, that. So that takes care of that. We don't have a KMS ID yet. I'm going to put that in single quotes because I'm not sure exactly how it'll deal with the backslashes. We'll figure this one out. We'll figure this one out. We need security groups. Oh, I'm going to, yeah, remember what we did here? We had to separate these, right? These are the rules that go along with the security group. So I'm going to say mg mt security group. And this will look very similar to this. Okay. We're not even going to add any rules to this. And the reason we're not going to add any rules to it is we're going to use Session Manager to get access to it. So it's just talking to a service, right? We don't have any actual requirement for any ports to be open. But we do need to get some information into an export here. So we'll say value ref we'll just call it everything again. Okay. So that's that part. If we go back over here, I need the import statement, which I can never remember. I'll probably find it here somewhere. Yeah, this is what I'm after. Okay, so that's SG stack, and we just need the, I think I just said MGMT. Let's check though. Okay, MGMT SGID. Okay, there we go. Perfect. Now, the one thing that I didn't check was, does it want the name or the ARN for this? So let's have a quick look at that launch template config again. I think I looked at it, but I forget already. Oh, it'll take the name or the ARN. And I better make sure that we've got this set right. Instance profile. Okay. So we will use the ARN. So that takes care of that piece. So we have a to-do up here for our KMS key. I think that's the last to do. Okay, so it's funny. I thought this. I'm like, oh, we'll just set up an EC2 instance. No big deal. More work than I envisioned getting this set up. We are going to need some parameters at some point. KMS. There we go. So we want to create a key. Okay. Now the key policy. I'm going to show you how I do this. First thing is we need this first statement to allow basically management of the key. Okay. And it's interesting. ID. Let's have a quick look at something here. I can't remember if that little piece is required or not. Yeah, it doesn't have that, so we're just going to say statement. And here we want to do okay. And then we'll say chin AMS. This I never, we're gonna try it without the single quote. We'll just do that, and then we're gonna say, I think you have to do it with a quote there. Okay. So this is just essentially setting it up so that the AWS account that owns the key has full access to the key. Okay. And then what we also need to do is, what's this say? Allows the account to use IAM policies to allow access to the key in addition to the key policy. Okay, that's what this does. It reduces the risk of the key becoming unmanageable by giving access control permission to the account admins, including the account root user, which cannot be deleted. Okay, that makes sense. Oh, and then this is a statement we can set up for key administrators. We're not going to worry about that one. And then a lot of times what I end up doing is if we go back over here, I find some of the documentation not necessarily super clear on what your key policy should look like. So we're going to go into, KMS. And we're going to look at keys that are managed by Amazon. And there should be an EBS key in here already. And this is the key policy that we want to set up. So we're just going to match this. Allow direct access to the key metadata to the account. So that's what we've got already. Oh, they've tightened it up, actually. I like this a little better. Oh, okay. Up here. Allow access through EBS for all principals in the account that are authorized to use EBS. That's our key policy. And then describe, list, get, revoke. Allow direct access to the key metadata to the account. Yeah, I think I'm going to leave what they're talking about here. The following key policy statement is the entire default key policy for KMS created programmatically. It's the first policy statement in the default key policy for KMS keys created in the management console. Gives the AWS account that owns the key permission to use IAM policies as well as key policies to allow all actions KMS star on the KMS key. The principal in the key policy statement is the account principal, which is represented by an ARN in the format of blah. The account principal represents the AWS account and its administrators. Okay. All right, perfect. I think we're good with that. Now we are going to need exports here. So let's do outputs, and we're gonna set an alias for this too. I forgot. So we'll say EKS key alias. Specifies it must begin with alias. So we're going to do right. And then we will, from here, have a look at our return values. Probably the key ID is the enough. So let's do EKS key ID. The value is ref EKS key. The export then has a name, which we'll just use. Same things we've done over here. So we'll just call this EKS key ID. I'm going to also export the ARN just in case we need it for some reason. Might as well just do it now, right? Okay, so that's good. So we have to add that again to here. Oh, you know what we did? We put this parameters section in, which we didn't use. I don't think it supports, it does support tags. KMS key, okay. So then we got to put that back. So we'll just grab this. Right? And then we can just, again, borrow off of these, grab that, attach it to, oops, here. Okay, perfect. So that'll set up the tags as well. So that's that. We don't need this. Now we've made a lot of changes to this, so it'll be interesting to see how far this actually makes it. So let's do this. CI added KMS A lot of changes. I'm suspecting, oh, we left it to do. Oh, oops. Okay, let's fix that first. Now this is specifically saying ID, so we will grab this. Okay. There we go. Too many changes to not expect this to happen. So what do we got wrong here? Security SG error occurred. Template format error. YAML not well formatted. Line 106. Oh. So still in SG. Now we have line 114 not well formatted. Oh, look at that. All right. A little better. Didn't fail immediately this time. Ah, there we go. Made it a little further. So now we're in EC2. Invalid parameter property default value. Okay. Oh, that must mean, yeah, right here. See what I did? Default value for some reason. This is why you don't make so many changes at once. Unresolved resource dependency, volume type. So I got a spelling mistake, see right there. All right, there we go. So KMS is deployed already. So if we go back over here, I saw that fail just as we came back here. Malformed policy document. I think it's not going to like this. I'm going to start there just because it's got the star at the end. Oh, the last pipeline failed too. Didn't like EC2. Well, that's weird. Oh, this is probably because, yeah, see this? It's in delete in progress. I was a little too quick. Okay, that's fine now. So what we'll do is we'll ask it to retry this one. We also changed IAM, we changed security groups, and then we can deploy this, but this failed. So let's see what's wrong with this. Profile, command not found. That probably is just a spacing issue again. Oh, look. So let's see here if this is going to work for us this time. We could also look at this. It should have a change set here. Right, because we are modifying a role. What are we modifying there? We're modifying two roles. Oh, we added the tags. So that's what we're after. Hey, Kevin, how's it going? Good to see you. So yeah, that's why we see the modify on those two roles that existed. KMS failed on us again. Let's see if we can get these other ones deployed. So we'll let that run. Here's the security group. It should also have a change set. So we're adding our new security group. So that's good. There's our EKS. That won't deploy successfully because it requires this. Yeah, malformed policy document. Ugh, it's the worst error. So we'll let that go. We'll let that go. I'm going to look at an existing policy document for this. Just give me a second. I don't want to get too bogged down in trying to figure it out. T-ball game tonight. How'd it go? Yeah, it's going well. We're building out. I wanted to create a little management EC2 instance so that we could use that for Cube Ctl commands rather than messing with my workstation. So we're working on that. It's turned into a little bit of a bigger project than I had originally envisioned. And I just want to look up a key policy here. It doesn't like our key policy, and I'm not quite sure why. Yeah, it is funny, isn't it? I said earlier that I'm trying to build out a template that covers off all of the kind of security hub checks. So that's what I'm kind of trying to work on. Okay, so let's go back over here and figure out if we can see what's wrong with this KMS policy. I'm looking at another policy that we built that kind of does the same thing. So it definitely doesn't need that. Version 2012 1017 statement effect principle. Root, so that looks good. Resource star, okay, and then we have effect is allow principal AWS star. Describe key, that's fine. Resource, and then condition. String equals KMS via service sub EC2 dollar AWS region.amazon AWS.com KMS caller account. Oh, I did miss something here though. I don't know if that was the problem or not, but I need key usage also defined, which is for encrypt and decrypt, and I've also got pending window in days, and we're just going to say pending delete, and we'll add that up here. Okay, and now we're just going to leave the default at 7, but I think you can go as high as 30 or 35 days. The only difference I could see is in the caller account ID, I used a sub here, and over here I used a ref. Now I don't know why it wouldn't work, but let's try that and see. Okay, repush that. So have the T-ball game go. Did you win? There goes KMS again. At least it's going first. Here's our KMS. We should have a change set. Great. Let's execute that again and see what it does. A whole whopping 3 innings. As long as they had fun, that's all that matters, right? Ah, still not right. Okay, let's have a look at something that's more serious here for a second. Oh boy, Toronto's in trouble. All right, so we've still got a malformed policy document. It's going to be something really stupid. Key policy version. Oh, look it. What did I tell you? typo in key policy. I told my buddy the other day, we were talking about the playoffs, and both of us, you know, Leaf fans for life, and he's far more optimistic than I am. And I said, I hate to admit it, but I think it's going to be Tampa in 6. And he thought I was nuts. I hope I'm wrong, but let me just say I've been a Leaf fan long enough to know at this point that I won't be surprised. I'm actually going to text him right now, and let's see how badly he's freaking out. I'll give you an update when I hear back. He's probably a little tightly wound. Pass, pass, pass. Did I actually push this? I don't think I did. Yeah, there we go. Yeah. Your Penguins are looking pretty good. They're up 3-1 now, right? So that's good. Hopefully that was just the spelling mistake. Oh, look what I did too. I guess it doesn't matter. It's KMS at the end. It's like I didn't follow my own non-existent naming standard. Okay, there we go. That's a little more hopeful. Yeah, I don't, I purposely don't have any sort of notifications or whatever so that I don't think about it too much. He's not responding. He's probably lying face down on the kitchen floor right now, just trying to calm his breathing down. All right, so the KMS, for whatever reason, a key takes a little bit of time to generate. So we've got, let's go through these other profiles and just make sure, or not profiles, stacks, and make sure there's no other stack updates to do. Everything else is good. Okay. So, oh, phone's buzzing. Here we go. Outshot 14-4. Ridiculous. Yeah. All right. So once we get this going, I think what we'll do is we've been streaming for about an hour and a half now, I think, close to. I think we'll just make sure that we can get access to the EC2 instance through Session Manager, and at that point we'll call it a night, and then I can go watch my my Leafs get themselves in a situation where they probably can't get themselves out of. Let's see here. Okay, so we've got the key is done, the alias is almost done. Well, I say almost, I don't know. Shouldn't take too long to set up a alias. Unless I put something in the name that it doesn't like, which would really suck. Although you'd think it would fail pretty quickly. Let's see here. Let's go over to KMS. And can we look at customer managed keys? Okay, there it is there. So this is our alias, okay, which points to our key, so that's good. It's just taking its time. Does it have its outputs yet? It doesn't. So I've got to wait for the outputs in order to run this. Okay, there we go. Done. We've got our outputs here, and let's run this change set now, which is gonna, for now, oh yeah, we only created the launch template. We don't have the EC2 instance. So let's see if the launch template launches. Oh, parameter value, demo key for, oh, okay, that's my fault. I was looking at the wrong region. So we don't have that demo key that I set as the default. So we can go where? Key pairs. I'm going to delete this one because it's not being used. And then we'll create demo-key. Okay, the good thing is that we can simply go back over to CloudFormation. Okay, that's gone. And then we can just rerun that one stage because we didn't actually change anything in the template. There it is. Launch template EC2 optimized or EBS optimized does not match Boolean. Oh. Yeah, there we go. Okay. Just delete this. Push that. See what happens here. Well, it should go pretty quick at least. All right, there it is. Hopefully there's not too many typos in that launch template, but there's a fair amount of stuff we wrote and mappings that we're using in interesting ways. So I'm hoping, oh, metadata options, HTTPS tokens. I think it's just supposed to be HTTP tokens. Spoke too soon, didn't I? Where's EC2? Right there. So we're looking for metadata options, and it's HTTP token. HTTP tokens, okay. We're working our way down the template. Let's look for other spelling mistakes. This is a good one. Specifications. That looks okay. Specifications, resource type. Well, let's see. Yeah, HTTP sounds right, right? Do you need to provide tokens for the HTTP request? Makes sense. All right, here we go. Third time's a charm. Didn't fail. Didn't fail right away, at least. Okay, there we go. So if we go over here and we go to EC2 and we go to launch templates, there is our new, I'm going to get rid of these because these are the ones that I was using for some earlier demos. So we'll get rid of that one and we can get rid of this one. So there's our new launch template. And it picked up the AMI ID, the specific instance type. Here's our storage volume, the tags that'll get assigned to the resource that's launched, network interfaces, advanced details. There's our instance profile. We've enabled termination protection. We've enabled detail monitoring, optimized DBS. There's the metadata piece too. So that looks pretty good. So what we can do now is we can quickly go over here. I say quickly, but we'll see how long it takes. We go to EC2 instance. Okay, and we'll just call this MGMT instance. This, since we're still, I want to put the depends on so that when we deploy this later, it makes sure that we cover everything. So it depends on the launch template. And then what we're going to do, so just have a look through this. All of this is supplied through the launch template. All right, so we need this info right here. So we can do the launch template ID or the launch template name. So let's just do launch template ID. We need to figure out how to refer to that. And then we can, there's a way to do this. And I always forget. So see, it doesn't support latest or default. I'll have to look this up. But what we can do is there's a, I think it's in the launch template output. So if we go back over to the launch template and we look at the return values. So the first thing is we need the launch template ID. So that's just a ref, right? When you pass the logical ID, it returns the ID of the launch template. So we can just do ref LT. That's easy. And then this is what we're after right here. So now we can do, so there are, what's good about the launch templates is they have multiple versions. So if we can change our launch template, we go from version 1 to version 2 to version 3. And then we can refer to the particular versions that we want. We can set a default version or we can use the latest version. I think in this case, we're just going to use get attribute lt dot latest version number. Okay, so that's that piece. And then if we go back, I need to play around more with AWS. Weather gets nicer and things get busier. Yeah, I know, eh? It gets hard to figure out or find the time to do all this stuff. Okay. Again, all of this is provided by the launch template. I think all we really need now are the subnet ID. So we can go subnet ID, and we will use this same thing right here. And we're going to make that our VPC stack, and I'm going to put this in a private subnet. I just have to remember how we outputted those names. So just like that. Right? Everything else, I want to say that everything else is defined up here. So I think, let's try this and see what it does. And while we're waiting, we'll see if the game's restarted yet. Still 2-1, still end of the first. Okay. Oh, failed. What didn't it like? Import value must not depend on... Oh, okay. So that means this VPC stack, I didn't add it here. And we should just check. Whoops. Check to make sure it's actually getting passed in here. Okay, so it's here. I just didn't add it. See how this goes. At least it's getting warm. It's 12 degrees here right now, and it's 20 to 9. So that's pretty good, all things considered. It's probably the warmest it's been. I'm sitting in the office here, and it gets warm in here. I can tell when the temperature starts changing. So this should add our management interface, assuming that we covered everything that we needed in the little EC2 template. Okay, there it goes. If we go over here, we go to instances. There it is. I like when you find mysterious things in your account. I'm sure this was just me. When was this launched? Tuesday, May 10th, right? That's today. At 1949. When all else fails, it's in the demo account. Everything is fair game. Terminate. Okay, so there we go. So this is initializing, and then you'll notice that I created a role for it, and the role, all the role provides us with is access to SSM. So in theory, we should be able to say connect, go to the session manager, and say connect. Perfect. So let's patch it up. And then the other thing I thought we could do, we've got a few more minutes. We'll, yeah, you forgot what sunshine looks like. I know what you mean. Okay, so that's patched. I wanted to find this here. So we'll install kubectl on this machine, and we're running a Kubernetes 122 cluster. So we'll grab this. Okay. Right. Actually, I'm going to, yeah, that's fine. That's fine. So that's good. Verify it. Well, what version did we get up here? I grabbed this, so it's 1226. That's 1226. Okay, so oh, look at this. There's a 123. Okay, whatever. I think that's what we want. Okay. And then we can run this. And what we want to do is compare the values here just to make sure that everything looks good. And then if we do, right, those are the same. Looking at the first couple digits here, 860C3, 860C3, and then it ending in 215A07, 215A07. Okay, so that's fine. Keep going the wrong way here. Let's close some of these windows. And then we want to make this executable. And I want to make this available to anybody because I know I'm logging in as the SSM user right now, but maybe at some point in the future, you know, I want to use a different user. So what we're going to do is we're going to say, we'll do sudo cp kubectl2 /user/local/bin/. Okay. So that way it's available to everybody. Again, don't need that right now. And then we can just run this to make sure that it works. Cannot execute binary file. What if I do? What did I do wrong? Did I download the wrong binary file? I'm on Linux, right? So that's fine. This is just here where I'm copying it to my own bin directory, but I just threw it in everybody's directory. Huh. What I thought would be the easiest thing, cannot execute binary file. What am I missing here? Download the binary for your cluster's Kubernetes version using S3. We're on Linux, so that's fine. Okay, so we got that. Verify the downloaded. Okay, that's fine. We ran checksum against it. We made it executable. We copied the binary into a path. So if I do which kubectl, it sees it. So that's fine. Oh, hold on. Maybe it's the owner of it because it's owned by root. So this is owned by us here. Read, write, execute, read, execute, read, execute. Okay, let's do this. You've come up with a Mac binary. Problem is you're using AWS. I guess I've just downloaded the wrong file type. Huh. I did this on my Mac without any problem at all. Let's do sudo yum install. I wonder if it's in, is it in the repo? It isn't. Isn't this funny, eh? What are the differences between these ones? Oh, look. Oh, this is it. I'm not reading. Look. AMD ARM64. So we have an ARM processor. Haha, mystery solved. You should always RTFM, right? So let's try this. Okay. And then we'll go through the same process again. Make sure we get the right one. So that's ARM64. What did we download up here though? 1226. So I would assume that it's the same checksum value right here. Right? And then we can do that command. Should look this, okay, yeah, different. And then we could go. I think I downloaded the wrong one. What did I download the first time? 1226, that's the same one then, right? I don't know what I'm doing wrong here. Let's just do this. Okay. And then this time, if I've actually downloaded the right stuff, I should be able to run that command. There we go. Okay. So we're good. I think we're going to call it here tonight. We've got our little EC2 instance set up. Next week, what we can do is get the kubectl command talking to our cluster and figure out how to run maybe even just a couple pods within that Fargate profile. And then we've kind of gone through the whole process of setting up the cluster, setting up the Fargate profile, and then launching some pods with Fargate being responsible for managing the underlying infrastructure. So good progress. I was hoping to make it a little further, but setting up that EC2 instance took a little longer than I had suspected it or expected it to take. Let's do one more quick look here at how upset we're going to be. 2-1, they're coming back. Coming back. All right, so enjoy your evening. As always, thanks for hanging out with me here for a couple hours as we muddle our way through some CloudFormation templates and a bunch of other things. Enjoy your evening, and we'll see you next week. Take care.